Welcome. In this tutorial, I'm going to go over the PowerPoint that we did on the live session in a little bit more detail. We're doing chapter 3, the relational data model. I've added a bunch of slides, which hopefully will help you, and I will post the PowerPoint of this as well. So here are your learning objectives, and I'm not going to go over them. They're already in the chapter and already posted. And basically, we talked about what a relational database is. It's just a logical view of data. And you want to be able to represent something in a visual way so that it makes it so much easier for you to design your database. And then here we have a characteristics. Basically, it's very simple, just a two-dimensional structure composed of rows and columns. I like to call them fields and records, the fields being the attributes and the field names of the table, and the rows being a set of like data, could be also called an entity. And the reason why it's called a relationship is because you can use the term synonymously. It's called a relation and a relationship model, the same. And here we have a characters table. It's taken from the book. It's in here. Now notice it just so each row tuple represents a single entity. You can use tuple if you want. You can use record as you want. You can use row if you want. And again, you have a column, which is an attribute, and each attribute has a distinct name. I, again, choose to call them field names. Then the intersection of a row and column is just like an Excel spreadsheet, and it has a single value in here. In a column, they must all be the same format. You know that either a number, text, a date. And then each column has a specific range of values known as an attribute domain. So if you have a certain age, you obviously need to make sure that is cannot be less than 0. We have keys over here, and we talk more about keys later on in here. And basically, a primary key is the most important key that you have. But keys are used to ensure that each row in a table is uniquely identified. That's what the primary key does. You cannot have two of the same primary keys. So for instance, you cannot have number 1 for student ID and another student have number 1. So duplicates are not allowed. Again, that's something we've talked about. Determination basically is the value of one attribute is determined by the value of the other, and also many more. So when you're pulling up a record and you have the student ID, it gives you the last name, the first name, the address, the phone number, the advisor, and a whole bunch of other things, probably the GPA as well. Then we have functional dependencies, and I'm just going to read that as I've written a definition. It's where one or more attributes determine the value of one or more attributes. Again, student num determines what student last name is. So then we have determinant and dependent. Determinant is the one that value determines. So student num would be the determinant, and student last name would be the dependent. Full functional dependent is an entire collection in the determinant is necessary for the relationship. That would mean that course ID and section ID determine class size. Course ID by itself or section ID by itself could not do that. Then we have types of keys. Again, composite key, key attribute. We talk more about that later on. Entity integrity is just simply a condition in which each row in a table has its own unique identity. So again, all the values of the primary key must be unique. We talked about that. And a primary key cannot contain a null. So again, we have the primary key. The definition is used to uniquely identify every row in a table. And again, the same value cannot appear more than once. Here are simple rules. You cannot have two rows, cannot have the same primary key. We talked about that. Every row to have a primary key. The primary key cannot be null, and the value of the primary key cannot be modified or updated if any foreign keys refers to that. A foreign key, of course, is something that refers to that from another table. So then I have a super key. We're not going to be dealing too much with super keys and candidates. We're going to be dealing primarily with primary keys, foreign keys, and alternate keys. And again, a super key is just a group, and this is a definition of single or multiple keys, which identifies rows in a table. But remember, the super key may have additional attributes that are not needed for the unique identification. A candidate key here is a super key with no repeated attribute, and it's called a candidate key. And here are the properties. Unique, it can have multiple. Again, no null. It should have minimum, and it must uniquely identify each record. It kind of sounds like the same definition over and over again, just worded differently. Now we have a secondary key. It's just strictly for data retrieval purposes, such as a city. You want to, or a phone number or area code. Then again, the primary key of one table has been placed in another key. We're going to use that for a foreign key. So if you have a student table and an advisor table, somewhere in the advisor table, the must have the student ID. The student ID in the advisor table is going to be the foreign key. And then I have an example here, a customer ID in both a customer table and an order table. Again, keys, we don't want null. Really very, very, very rare that a should ever have a null in here. Keys definitely not going to have it in here. Referential integrity, every reference of an entity is entity instance by another entity instance is valid. So you're going to have two different tables. So if you have a customer ID in one table, it needs to refer to a customer ID in another table. When you did your relationship in Access, one of the options was referential integrity. And if it did not work out properly, it would not let you do that. So again, you can see more definitions, basically the same thing over here. Here's an example of a simple database over here. So you can see the vendor code refers to the vendor code, from the vendor code to the product file. And again, here are the integrity rules, very simple. But for referential, a foreign key must have either a null entry, and that is okay, as long as it's not part of its table's primary key. And the reason for that is you might have a student that might not have a advisor assigned yet. Sometimes what they normally do is create a 99 for advisor ID or 00, so that just means not assigned yet. And again, we have more illustrations of integrity rules in here. So entity integrity, I've defined it for you. All primary key entries are unique and no part of the primary key must be null. So here we have the customer table's primary key is cuscode, and again, it has no null entries and are unique. The agents table has no entries and all are unique. So here we have it. That's going back to it. And we talked about this again. So this is just more words that are saying the same thing over here. So you can have a customer table as a foreign key agent code that links to entries in the customer table, but the customer code has a no entry because the customer does not have an agent assigned to it. Very similar to what we did when I talked about with the student file and the advisor. Again, flags are used to indicate the absence of some value. We are not going to do much with relational algebra, but just want you to know it. Basically, RelVar, it's basically just has two parts. It heading that contains the name of the attribute and body that contains a relation, but it's not the actual relation itself. So again, we have project, union, and intersect. You'll see over here. And we have different things over here. So we have an original table and a new table. So it's select, basically select with a star is going to give you all of the fields and all of the records. So here we have select only price, that's less than 2. So you're going to do select price from table, and then you're going to do where the price is less than 2. And same thing with select only P code for 311452. So that's very simple in here. So you learn more about that with SQL. And again, we have the project over here. Again, it just yields the price over here because that's all we ask. And then description and price gives that. So you can modify them however way you want to do that with a simple SQL statement. Union and figure intersect. Union and intersect are basically just the same thing as you learned in math. The union is the combination of everything, and the intersect is only the common ones. So you can see for the intersect, we just have Franklin Johnson is the only one that's in both of them. Where with the union, we did all of these. Now the rows are not repeated, but we did all of them in both tables. The difference yields all the rows in one table that are not found in other table, and the product yields all partial pairs of rows and tables. And I have some examples. So here's the difference. So we want to know everybody that's in the one table, not in the other table, and it gives it right over here, all 4 over here. So that's pretty easy. And again, the product is basically you're going to be multiplying each and every one, so you're going to have a lot more cells in this table than you do, or rows in this table in here. So you can see you have 1, 2, 3, 4, 5, 6. We have P code, description, price, store, aisle, and shelf, and then a whole bunch of rows or records. Joins and divides are fun. Join is really easy. Basically, we're going to be dealing mostly with a inner join, and that's basically you set a condition where the 2 tables, I want to have all the customers that live in Miami. And a divide uses a 2-column table and a 1-column table, and I'll show you the output in that. So the output's going to be a single column. It contains all the values from the second column of the dividend associated with every row in the divisor. Now that sounds a little tricky, but I have a little thing in here. So we have 2 of them. So you can see we're dividing this into here. So basically we need every customer that's going to have this P code in here. So 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7, 5, 7, 8. So we have to find that. So 130 is going to have all of these in here. 12550 is going to have all of those in there. If it was missing one, it wouldn't be in there. And I've given you a little easier example. We want to know every customer in the first table that's eaten in every restaurant in the second table. So these customers must have eaten in restaurant 1, 2, and 3. So you can see customer 1 has eaten in 1, 2, and 3, and customer 2 has eaten in 1, and I think I did a typo. I did it twice. So, but you can see the point over here. Only customer 1 have eaten in every restaurant. SQL joins is from structured query language. We're going to learn more about that in chapter 7. Basically, we're going to be doing primarily inner joins. And here's the syntax for it. So you're going to select and you're going to name all the columns. So for instance, select cust ID, cust name, cust address from table, and then you're going to do inner join on, say, like an invoice table where invoice.custid equals customer.custid. And here is an example of an order table in here. It's not a complete, just wanted to do the part so you can see that you have an order table and a customer table, and this is how you would actually do it. Select orders ID, customer.name, so on from inner join, and it will give you all these in here. So basically it tells you every customer that's done an order. And here is another illustration. This is in your book as well. So I've given you the select code from it, the SQL. So you're going to select cust.custName, last name, agent.agent, phone, and from customer. And then that's all we have is these things over there. Select cust last name and agent in here from customer, and inner join on customer agent code where agent code equals that. So basically, as long as the agent code meets in here, so we have agent code 231, agent code 231, so that should show up in there. An outer join is a little bit different. We have 2 joins, one is the left, one is the right, and I've given you some illustration. So basically, it gives you all the rows of the first table, including those that don't have a matching row in the second one, and the right is just reversed. So here is the syntax for that. So you're going to select from table, left join, and you can use just join. You don't need to worry about outer join. And select customers, and you can read the rest of it. It returns all records from the customer table, even if there are not matches in the orders table. And the right is basically the same thing, only does it in reverse. So the right returns all records from employees, even if there are no matches in the orders table. And here is an example of how the join works. So you can see everything is going to be here. If it's in this table, fine. If it's not in this table, it's not a big deal. But it's everything here. The right join is exactly the opposite. Data dictionary is important. I want you to understand that. And it's just a description of all the tables in the database created by the user and the designer. You want to do that before you create the database in here. Homonym and synonym are basically the same thing as what you're used to in language, but they're very dangerous, and I'll show you in the slide over here. So we have an F name and an F name. So we think it might be first name. But the problem is it stands for father's name in one table and first name in the other table. So you need to be very descriptive in your name calling. So I would call the father's name or first name, or be very, very careful in here. One-to-one relationships, one-to-many relationships, and many-to-many relationship. It could be M to M or M to N is just fine. But basically, mostly we're dealing with one-to-many and one-to-one. One-to-many really needs to be understood. One-to-one is not quite as common, but it could be a husband and a wife table where they're married to each other and they can only have one husband, and a wife can only have one husband, and the husband can only have one wife. What you're going to do with the many to many is break them up. So you can see you have a many to many, and that's defined over here. This is actually one to one, and you can tell it's one to one because this means one and only one in here. So you can only have one professor, can only be in one department. Here's the many to many. So you notice you have students have many classes in here. So to make it simple, you break it up into something called enroll or whatever you want to call it. So the student registers and then the class has an enrollment in here. So you have a one to many and then a one to many over here or many to one, however you want to do it. And then again, this is just another example of the ER model over here. Data redundancy, again, we talked about that. It's very, very important that you do not have data redundancy in your databases in here. And here is another example of the invoicing system. So you can see we have a one-to-many here, a one-to-many here, and a one-to-many here. So this takes good design. That's why you go into Access, and we do it in Visio as well, and you're going to create the actual relationships. It's really very easy. Indexes, again, we talked about it before. And we have basically, that's it. So I look forward to seeing you all again. I hope this was helpful. It's given me an opportunity to explain a little bit more in detail. I didn't want to just read the slides. I wanted to go over them. But what you can do is take the slides. I have some reference points that you'll be able to see. And if you have any questions, please feel free to let me know. Hope you have a wonderful day.